right, so we're going to look at the last section today. We're going to spend 2 days going over this. So the first part, start out somewhat simple. We're going to look at the trig form of a complex number. So we've already worked with complex numbers before, correct? Right? So as you look at the complex form of a number, you got your real part and your imaginary part. We're going to plot that in what's called the complex plane. It looks just like a coordinate grid, doesn't it? But over here, the x-axis is for your real number, and your y-axis is for your imaginary number. You did this in Algebra 3-4, correct? Well, you should have. Who'd you have?
Mr. Boyle.
Oh, yes, you did.
No, he didn't.
Yes, you did. I tutored his students.
did.
Okay, neither here nor there. It's really easy. Are you ready? So the real is your x-axis, right? The imaginary is your y-axis. So for here, if I'm going to plot the imaginary number 3 plus 2i, I'm just plotting the point 3, 2. So I go to the right 3 and up 2. Right? No big deal. Then we've got, that's no problem. Then we've got the definition of absolute value of a complex number. We're going to use the absolute value in some other calculations. So you need to know how to do it. So here's your complex number. They like to call the complex number Z for zippy. And this all, I just thought I'd jazz it up for you. And all they're referring to is they just don't want to write a plus bi all the time, but they still do it z equals, they just make it longer. So here's your real and imaginary part. We want to take the absolute value of that. What does that look like they're doing? It's like the magnitude or the distance formula, isn't it? Because really what they're doing is they're taking, if I were up here to connect from the origin to here, wouldn't I be making a vector? Yeah. Right? And so they're really finding the distance from 0 to that complex number in the complex plane. So you might want to write yourself a little note that this is the distance between 0, 0 and the point AB. So look at example 1. I'm just waiting for everybody to finish in case you're wondering. All right, so example 1. You are to plot 4 plus 3i and then find its absolute value. So let's go ahead and plot it. So the x value is 4, so to the right 4 and up 3. So this is 4, 3, or 4 plus 3i. And then, when we find the absolute value, we're really finding this distance, and distance is always positive, so that's why we want a positive number right there. So now you find the absolute value. You do it. Oh, is that what that noise is? I was wondering what that noise was. You're okay. Life is good. Okay, just settle down. Are you okay? Are you better now? It's gone. It's not Danny's fault. Danny's okay. Danny, continue. All right, so aren't we going to take 4 squared plus 3 squared, poor thing. You get 16 plus 9, square root of 25, which is 5. So this distance here is 5. Say that again? Nope, we don't do anything with that.
Okay.
All we're looking at are the coefficients. So we could have used Pythagoras' theorem also, couldn't we? Yes.
That's it?
That's it. That's not hard, right? Yeah. But you know it always gets worse, right? It gets better before it gets worse.
I don't want to think about that right now.
All right, so flip it to the back. So then we're going to look at the trig form of a complex number. And we're going to use this formula here. So we've got this thing called R times cosine of theta plus I sine of theta. That looks kind of similar to when we were finding the theta, right, with vectors. And they gave you the directional angle, and then they gave you the magnitude, right? Didn't we use a formula that kind of looked like this? Where R was the magnitude, right? Do you remember that? So it looks very similar, doesn't it? So here's R. What is R really? Absolute value, right? And so as you can see in the coordinate grid, R is your radius of your unit, well, radius, I want to say unit circle, but it's not necessarily a unit vector. And then A is the distance, is your horizontal distance, and B is your vertical distance. So it's really nothing different than what we've had before, but we're just applying it to a complex number. And just to be clear, this is your X value because it's cosine, and this is your Y value because it's sine. So then I have put here the steps that you're going to follow to find your trig form of a number. So I would definitely learn these and study them before next Thursday and Friday. More specifically before Friday. You've got 1 week. The very first thing we're going to do is find the quadrant that our complex number is in. Then you're going to find R, which is your absolute value. Then you're going to find theta. Haven't we found theta in the past using tangent, inverse tangent, reference angle? And then we also have to pay attention to sine. That's why we need to answer for the correct quadrant, because sine is important. And then you're going to finally write it in trig form. So, following those steps, let's look at 2 different examples in example 2. One example, we're going to write our answer in radians. And one, we're going to write our answer in degrees. And you'll be told the answer needs to be in radians or your answer needs to be in degrees, so it won't be, you know, a guess for you. Oh, one other thing I forgot to mention. Writing a number in trig form is also, the trig form is also called polar form. We will need this later also, so it doesn't go away. It never does. You started to learn that 4 years.
I remember when I was a freshman and I had to say
And your teacher said?
Yeah.
No. Yeah, factory never goes away. All right, so then let's look at this one. So step 1, I want to find the quadrant. So we're going to go ahead and plot this. Even though I don't know exactly where negative 2 rad 3 is, I know it's to the left of negative 2, correct? So you don't have to worry about super exacts. You're just going to put it in the quadrant that it belongs and draw a point there. If somebody gets the door. So if I have a negative A and a negative B, what quadrant is that going to end up in? Thank you. The lucky person is Mike. You get to... that would be bullying. Michael, I'm going to be sorry to see you go. Zach, would you like to apologize? That's right. Mom's waiting or somebody's waiting. So don't forget to do your homework. Finish watching the video.
Nice.
Thank you, Joey. That was very nice of you.
I'm just not going to say anything.
Now, if you don't have anything nice to say, don't say anything at all, period. Got it?
That's why I'm saying.
All right. Boys, let's finish up. Don't forget your homework, Michael. So, what quadrant, if you have a negative A and a negative B? That was rude, guys. Just saying, and we'll discuss it in a minute. But if you have a negative A and a negative B, what quadrant? Third quadrant. So I'm just going to put a point here. Okay, that's the quadrant that it belongs in. You know, don't have to focus on exactly where that point belongs. I wouldn't stress over it. So this is really -2, comma, -2 rad 3. Or if you want to write it in its complex form, that's fine. But I'm really focusing on that A and that B. So I can create a reference triangle. Go straight up to the x-axis. And what I'm going to end up finding is the angle from here to here, right? I'm going to end up finding that angle. What's this distance from here to here? -2. And what's this distance from here to here? -2 rad 3. So next we do have to find R, right? So R belongs here. So that's our second step. So R equals what's wrong? You okay? So I'm just going to take each one of these and put them in here. So I'm going to square -2 and square -2 rad 3. Right? So I get 4 for this one. When I square the -2, I get 4 times, when I square radical 3, what's rad 3 times itself? 3. So I actually get 4 plus 12, which is square root of 16, which is nice number 4. It won't always be a nice number, but here it is. So R is equal to 4. So then the third step says, or part of that third step, I guess you could attach it to the second step. We're going to find theta by using the tangent, right? So tangent of theta. Tangent is opposite over adjacent. So according to this, what's opposite? -2 rad 3. And adjacent is -2. Don't the -2's cancel? Right? So we're finding the tangent of the square root of 3. So you can take your handy dandy calculator. Now mind you, we want our answer in radians. So a lot of you are going to probably be more comfortable with looking at the degrees, and if you don't know exactly what the radians is, you can use your conversion of pi over 180, right? So take your inverse tangent and put in radical 3. And there shouldn't be a surprise as to the answer that you get. What'd you get? Why is that not a surprise? Theta is across, theta is across from rad 3 because it's rad 3, it's opposite over adjacent, so it's rad 3 over 1. That means that opposite of theta is radical 3. Isn't that usually 60 degrees? Question. We are. We're getting there. Yes.
So you don't have to do that.
If you recognize that, right. So then we put in our calculator the inverse tangent of radical 3, and we got 60 degrees. But we want radians in the third quadrant of 60 degrees. What would that be? Well, first of all, it's pi over what for 60 degrees? Pi over 3. So what is this? 4 pi over 3. 4 pi over 3. We'll get it there. And so then finally, now that we have our correct degree in radians in the proper quadrant, now we can write in our trig form, and we're going to use this right here to write it in our trig form. So step 4, I'm going to take my z equals, I'm going to take my r, which is 4, and and then multiply it by cosine of, and then we came up with 4 pi over 3 for theta plus I sine, and our theta again is 4 pi over 3. And that is your trig point. You're not going to do anything more with that. Yes. Yep. You okay with that? Jane, you okay with that? Yeah. Okay. All right, so that's our radians. So then how is it different if we do something in degrees? So if we had done this in degrees, by the way, everything would have been the same. You just would have put 60 degrees here, right? No, I'm sorry, I lied. We wouldn't put 60 degrees. What would you put there? What is 60 degrees in the third quadrant? 200 and... No. Yes, 240. I don't know why I thought differently. Have I mentioned it's Friday after a very long week? Yes, 240. Thank you. All right. I just wanted to see. All right, so let's look at this one. You're back. I thought you were leaving. Dude, she's giving you something? All right, so then let's look at how is it different than degrees? The only thing that's different is your very last step. So we're going to go ahead and find our number in complex form. I'm sorry, our number in the quadrant. So this time I have a positive A and a positive B. What quadrant is that going to end up in? Yeah, so I'm going to go to the right 6 and up 2. So this one I actually can know in somewhat detail where I'm going. I'm going to connect the distance from that complex point to there. And then I'm going to make my reference triangle. So I know that this distance here is 6, this distance here is 2, and that this time my theta is right here, and it isn't this r. So I need to find r. And you go ahead and find it. So you're going to take your ordered pair numbers, square them. And this time I don't get quite such a nice number, do I? So 40 turns into 4 times 10, right? 4 is your only perfect square. So the square root of 4 is 2. I can't take the square root of 10. So there's my r. What do I do next? Find theta. Using what? Tangent. So we've got tangent of theta is equal to what over what? 2 over 6, which is 1/3. So we're going to put in our calculator theta is equal to the inverse tangent of 1 divided by 3. So do make sure on your own calculators, by the way, that your calculators are in degrees. So inverse tangent of 1 divided by 3. Round that to 2 decimal places. So we've got 18.43. So 18.43 degrees. So now we have our degrees, we have our r. All you have to do is write z equals, your r is 2 rad 10, and then parentheses cosine 18.43 degrees plus pi sine 18.43 degrees. So second time around wasn't so bad, was it? Now, you're probably not going to put that into radians. So the only types of numbers that you'll put into radians are 30s, 45s, and 60s. Okay. Question? You think we're done? Almost. Flip it, yes. We're not doing them all today. Yes?
I don't have to solve, but
No, that's as far as you go. So block that out. That's your answer. All right, so flip it. We're going to do example 3, and then we'll stop for today. Yes, that's why we're breaking it up into 2 days. So now you're going to write your complex number in standard form. What's standard form? Yeah. Here's your standard form right here, a plus bi. Notice what you've been given. Are we just going backwards? Okay. So step 1 is to find your quadrant, because that'll tell you what your signs of A and B should be. Step 2, get your exact value. I'll show you what that means in a minute. And then step 3, you're going to simplify with no decimals. Okay, so let's start with step 1. Let's figure out what quadrant we would be in. Why do you say fourth? Well, but you got negative pi over 3, right? So negative implies you're going in the clockwise direction, right? So here, from here to here would be negative pi over 3, right? To that point. So I know that I'm in quadrant 4. So then we're going to find an exact value, because all I know right now, don't I know my r also? So I'm going to go ahead and put r right here of square root of 8. And I don't know either one of these sides. But I kind of need to know both of them, don't I? So I'm going to use what? What can I use when I have the hypotenuse? Sine, cosine, or tangent? Sine and cosine. And if I find sine and cosine, isn't that my A and my B? Cosine is my A, sine is my B, right? So then step 2, we're going to take the cosine of negative pi over 3, and we're going to set that equal to, we're going to call this y and this x, or you could call it a and b, but I like y and x because that makes a little bit more sense to you right now. So we've got, for cosine, is it opposite or adjacent? Adjacent over hypotenuse. We're going to do x over square root of 8. How are we going to solve for, well, we don't even need that. Do we even need this? What kind of number is that? What degree is that? 60. So what's the cosine of 60? Because normally you have what out here? If this is a 60-degree angle, what's across from it? Yeah, so negative rad 3. And then over here, what's adjacent to it? Negative 1. And then this would, of course, be... Oh, I'm sorry. Yes, thank you. Don't know what I was thinking, positive. And then this would be what? 2. So our cosine is going to be what? 1 over 2. It doesn't matter that we have the square root of 8 there. Isn't our cosine 1 over 2? Because this is normally 2 in our pattern. So we don't even need this. This is equal to 1 over 2. And then what's our sine? Sine of negative pi over 3 is equal to, sine is opposite over hypotenuse, so negative rad 3 over 2. So, step 3, simplify with no decimals. So we're going to take our original problem that they gave us, which was z equals square root of 8 times the cosine of negative pi over 3 plus I sine, I feel like saying I pi, I sine, but I'll manage to stop myself. And then we are replacing the entire cosine of negative pi over 3 with 1/2. And we were replacing the entire sine of negative pi over 3 with negative radical 3 over 2. So we get equals square root of 8. Instead of the cosine of negative pi over 3, we've got 1/2 plus I times, instead of the sine of negative pi over 3, we've got radical negative radical 3 over 2. Can we leave my answer that way? No, because we need to have it in the a plus bi form. So I can go ahead and distribute my rad 8, can't I? Do you want to simplify that or not yet? Okay, so we'll wait. So then we've got rad 8 times 1/2, wouldn't that be rad 8 over 2? Plus, and then rad 8 times 3, so actually that becomes a negative. We'll deal with that in a minute. So plus a negative rad 24 all over 2, and isn't that I? You ready to simplify? Because I have to distribute the 8 into here, don't I? Isn't the 8 on the outside? So rad 8 times 1/2, didn't I get rad 8 over 2?
No, not that part.
What, this part?
Skip the I.
The i's right here. Because doesn't the I in standard form come after the number? So that's why. Alright, so then rad 8, how does that simplify? 2 rad 2 over 2. And now I'm going to change my plus minus to a minus because we can't have double signs. And then square root of 24 simplifies to what? 2 rad 6 over 2 I. Make sure that I definitely doesn't look like it's under a radical. And then can't I cancel my 2's? And my final answer is radical 2 minus radical 6 I. So that is day 1. So your homework, 6 problems out of the book. Even though we have a 3-day weekend that's not code for, we're not going to do our homework. I would do it now so that you have nothing looming over your head on the weekend.